thank you for inviting us for the Alan Turing CBDH talk. Today, I'd like to talk about visual and spatial digital humanities research for Japanese culture, which is mainly done in ROIS-DS Center for Open Data and Humanities. And I'm the director of this center. DS is actually data science, so it's mainly my background is computer science, so I entered digital humanities research about 20 years ago. So I have been working a long time for digital humanities data, but my background is computer science. So ROIS-DS Center for Open Data Humanities, it was actually developed in, established in 2016. So it's a relatively new center. And we are working on two main topics, which one is data-driven humanities. So we like to use data for innovation in humanities research using computer science technologies and tools. So the second one is humanities big data. So we have many kind of data from the humanities, and we use such data for the innovation in non-humanities research, such as natural science and computer science. So we are working on two kind of topics like this. And basically in the open science, I think open science is an important word also in Europe. And in open science, it's very important to collaboration is very important. Like we collaborate between scholars, and also we collaborate with citizens. And we also use machines as a kind of collaboration partner to increase the amount of knowledge. So we like to connect those three types of stakeholders and use the data to innovate, to cause innovation in humanities research and non-humanities research. And one of the important project that that happened before CODH is called Nigel Network Project. And Nigel is actually National Institute of Japanese Literature. So they have a very big project now called to digitize 300,000 pre-modern Japanese books. Pre-modern means actually in Japan, it's before 1868. So they digitize pre-modern Japanese books and release them as open data. So this is a kind of first big data for Japanese culture, and but the literature people don't know how to process those large amount of data. So they ask us to help them. And then our center started in the same period. So we release many types of open data sets. And if you look at this website, you will see many types of data sets. But I'll introduce two types of data sets. One is a pre-modern Japanese text. It has 3,000 books with 600,000 pages, digitized pre-modern Japanese books. So it has, the characters are written in kuzushiji, and how to transcribe this kuzushiji by machines will be introduced later by Tarin Kalanwat, Dr. Tarin Kalanwat. And so I just skip them, but we have this kind of books as open data. And not only the raw data like this, but we also have open data sets, which is kind of created by ourselves. This is an example of this type of data sets called Edo cooking recipes. And it's actually 103 egg dishes created in the Edo period, which is more than 200 years ago. And so the recipe itself is actually difficult to read and difficult to reproduce. So we modify the recipes so that we can cook by today. So these are actually the photographs which is based on the modified recipe of the original recipe book. And we ask very professional people who cook these dishes and take a very beautiful photograph. So we release this as on the recipe site, and many people are interested in looking at how the old people created the food in a creative way. So today's topic is about visual digital humanities and spatial digital humanities. So I first would like to talk about the visual digital humanities. So our important development in the visual digital humanities area is called IIIF Curation Viewer. This is an open source software which has been developed since 2016. And I'm not sure that you have heard about IIIF, International Image Interoperability Framework, but this is a very important protocol for sharing or delivering images from a image provider like museums and libraries. So we use this IIIF and created a curation viewer, which is make the curation easier to do. I'll talk about curation later, but I'd like to first introduce the idea what we can do with the curation. So basically, we have an original image like this. And we would like to create a theme-based collection of a part of images. So we make a crop. So we crop an image, part of the image, and add it to the personal collection. So we draw a rectangle on the original image using a mouse or the fingers, and then add it to favorites. So by doing these simple operations, we can create a personal collection like this. In this case, it is a collection of faces collected from different Japanese artworks. So using the similar technique, we can create a curation like this. So this is a collection of the same person appearing in different artworks called Suetsumo Hana. So you can compare how the person is drawn differently in different artworks. And this is a facial expression data, British portraits from 16th century. So you can also see how the faces are drawn in a similar way or in a different way across different artworks. So this kind of curation can be easily created and published using a IIIF curation platform. And you can access this website to look at what you can do with the IIIF curation platform. So it is a collection of open source software, which is developed around the concept of curation. So we have JavaScript apps and Python scripts and Docker setting and so on. I won't go into the detail, but you can see this website for further details. So how you can use this kind of curation? And one typical usage is art history research. You can easily imagine that art history research, they are working on this kind of the concept of curation for a long time, because for example, they are interested in objects in the artwork, objects like faces. So you can collect the faces from different artworks and see the list of faces like this. So we can use IIIF curation viewer for cropping and collecting a part of images like this. And this software is called IIIF curation finder. So after collecting this part of images, we can add a metadata, and then you can search images by metadata on IIIF curation finder. And then you want to analyze or compare those facial images by grouping similar images or by grouping images of the same author. So this is actually a part of digital humanities research done by humanities scholars. So I'd like to show how we can use IIIF curation board, which is actually done by these humanities researchers. So after cropping these part of images, we can make a grouping on the two-dimensional space, adding kind of memo to the group. So this is actually grouped by these humanities scholars based on the type of the metadata added to the faces. And you can also add a stamp on it so that you can add a further grouping of the images. So using this kind of tools, the art historians can analyze 1,000 or 2,000 of images easily on two-dimensional space. So you can, and the advantage of IIIF is that you can go back to the original work so that you can actually check the context of the face. So you can see the detail of the face by cropping, or you can go back to the original work to check the context. So this kind of different views of the object is a very important way to understand the detail and the context of the artwork. Okay, so we also would like to introduce how computer vision can be used for this kind of work. So as you can see, this kind of face collection, it is actually face data set. So you can train deep learn
face image
learning for cropping faces automatically from the artwork. So this is a work done by internship student Alexis, who used RCNN, actually faster RCNN, to train how to crop the faces from the artwork, and applied it to these artworks. And this rectangle is actually the result of automatic cropping of the faces from artworks. So some numbers. So impact of machine learning-based face detection. So Kaokore, this is the main name of the face. Kao is actually a face in Japanese, and Kore is a collection. So face collection data set. So he applied his model to Kaokore data set, and the performance is about 80% of the faces were automatically detected. So that's fine. But the more interesting result is that about 70% of the faces were automatically detected when the model is applied to artworks from different time periods. So this is actually applied to the data that is not in the training data set and different from the training data set. But it was surprising for the art historians that even in this case, 70% of the faces were automatically detected. So what it means? So it means that if 2/3 of the faces are automatically detected by machines, so they actually need to crop the remaining part of the faces for their research, but actually they have to work only 1/3 of the faces. So it means that machines can reduce a large amount of work by humans. So this is a very useful result for art historians. And if machines are useful for speeding up this work, art historians can analyze more data. And more data leads to richer evidence and higher reliability of the results. So actually, the art historians can study more work, more artworks, and then they can lead to new discoveries from data-driven humanities approach. And another type of face data sets is called ukiyo-e faces data set. This is actually released this year. It's relatively recent results for ukiyo-e. Ukiyo-e is in the Edo period, so it's comparing to the Kaokore data set, it is later, and the target is also a type of different types of paintings, or actually woodblock prints. And originally, this Art Research Center of Ritsumeikan University released the ukiyo-e dataset, which is a kind of ukiyo-e, the whole ukiyo-e dataset. And after that, we work with, we collaborate with Ritsumeikan University to work on this data set. And after that, machine learning researcher from Google Brain, Tokyo, found that existing API can automatically crop faces like this. So it used this approach to create a new data set that is kind of object-based, like only contains faces. So the context is lost, but you can only focus on faces and then use it for further analysis, quantitatively or qualitatively. So this is, you can look at this website to download this kind of Wikio data set, and probably you can analyze using computer vision methods like the facial components, arrangement of facial components and compare how the authors, how different authors draw faces in different way. Okay, so this topic is a different topic, visual comparison of editions for printed books. And we have many printed books from the Edo period like this. But difference from European books is that we use many books are printed using woodblock. So in woodblock printing, you use the same woodblock for many editions. But when you have modifications, you change a part of the woodblock and then use the same woodblock for the other remaining part. So an important question is that which part was modified from one edition to another. So it's actually you have to do the visual comparison. And how to compare these two editions. So we have actually in computer vision, we have many methods for image matching or image restoration. And you use feature detection of feature key points and make a matching. So we can apply these kind of methods for comparing two woodblock images, like we detected these key points and make a matching. So using this kind of approach, we can directly compare two images of the same woodblock and then identify which part is modified. We call this a differential reading. We call this method differential reading because it is highlighting visual differences between different books with the help of computational algorithms. So you can easily focus on difference using the computer vision algorithms. So this is how to, I'd like to introduce a VDIF.js, which is a special JavaScript-based software designed for differential reading. So you can see that this red part and the blue parts. And so these are actually, these blue parts are from this edition, and the red parts are from this edition. So if you use a slider and compare, this part is absent, is missing in this edition, but this part appears in a different edition. So using this kind of pre-processing by computer vision, you can easily compare which part is updated. And then this is very useful for humanities researchers to identify the difference. And this tool also has a way to modify or improve the result of matching by computer vision, because sometimes computer vision algorithms fail to detect the important key points for better matching. So this tool has an ability to change the corresponding points in real time so that you can easily visually see the difference. And we use OpenCV.js to do this on a web browser. Okay, so I introduced some of the projects for Spatial Digital Humanities, and I'd like to talk about Spatial Digital Humanities from now. And we were using old maps to have a database of place names in the old city of Tokyo. It is called EDO. it is an old name of Tokyo. So I introduced the triplification viewer before, but we can also use this same viewer for annotation of the old maps. So you can see these map markers on the image. And so it looks like web-based maps, but it's actually a IIIF viewer with the markers on the old maps. So the marker locations are defined for the canvas coordinates. And if you're familiar if you're not familiar with IIIF, the canvas coordinate is actually a coordinate on the original image. So it's not like latitude and longitude, but it's a coordinate on the original image. But you can use this IIIF creation viewer as a kind of web-based maps to see and by clicking the marker, you can see a metadata of the place name like this. So this is another demo for EDO Maps. So unfortunately, this is written in Japanese, but you can, but this is a list of EDO Maps, which is created around 1950. And these are annotated by humans. And you can see, well, many markers, which is based on the transcription of the place names on the maps. And the classification is based on the the annotators. So this is a data, this is very useful to collect the old place names in the city of Edo. And if you click on the page for each place name, you can see the original map around the place name. We use this for this visualization. We use the IIIF creation viewer embedded, which is embedded version of IIIF creation viewer. So using these tools, we can create the database of place names. After that, we would like to have the latitude and longitude of the old place names. So for this purpose, we need a method called georeferencing. And georeferencing, there are many ways to do georeferencing. And but in this case, we use existing tools called Map Warper. Actually, this Map Warper is, for Japanese version, it's provided by Ritsumeikan University. And we use this service to create a correspondence of ground control point, GCP. And so the original map is provided from National Data Library, Edo Kiriezu. And so we pick up those unique points from old map and the current map. And using this map warper, we can make a georeference of the old map on the current map. So using this way, we can add a latitude and longitude for the place names. And yeah, you can also visualize it on Google Earth like this, that it is interesting to see that old streets are still present on the modern Tokyo downtown. And also these rivers are actually transformed into the road, wide road now. And after that, what we do is we use a GeoLoD. And GeoLoD is actually developed by us, which is an identifier designed for toponyms or place names. So originally, its place names is extracted from old maps and in the form of curations. So data format is curations. So they are converted to the gazetteer format for GeoLoD. And using this, you can, after registering this gazetteer to the GeoLoD, we have this GeoLoD ID assigned to this place name. And it also has a latitude and longitude. So this place is actually visualized on today's map with the latitude and longitude estimated from a georeference. So this GeoLoD is a kind of bridge between the old maps and the modern maps. After that, we would like to overlay what existed in the period of Edo. So one first data source is Edo Sightseeing Guide. So we are interested in how the people enjoyed sightseeing in the period of Edo. So we selected 2 travel guidebooks for each century. So actually we have many travel guidebooks, but we selected a representative 2 travel guides for each century. And also used the typification viewer to crop pictorial parts of the guide, travel guide and added metadata by transcription. This transcription is actually done by human, but yeah, this is kind of creating a sightseeing database. And also we assign GeoLoD and other identifiers to each entry so that we can make a link between the geographic information and travel guides. And another type of data which is overlaid on the map is Edo Shopping Guide. And we also have a shopping guide, which is pre-published in 1824. And we try to extract the name and address of merchants. So this is actually advertisement of the merchants in 1824. And this part is a place name. And this part is a type of business. And this part is the name of the owner. And this is a logo of the place, of the shop. So we transcribe this map information and also add the GeoLoD ID so that we can make a link between the these historical books and the place names. And this result is visualized on Edomi website, which is data portal for the historical Edo. This is actually released yesterday, so it's a very recent one. But you can see the distribution of geographic features like sightseeing spots and commercial stores in the city of Edo. And you can, so this is an imperial palace, and the shops are actually concentrated on the eastern part of this imperial palace. Today, the many shops are on the western side, but on this time, many shops are on the eastern side. So you can see, you can visually see how the business area is distributed in the area about 150 years ago. And the gazetteers created for GeoLoD can also be used for geotagging software, GeoNLP. So what the GeoNLP is doing is that we have a text, and in text we have many place names or toponyms. So extracting place names from the text is a very important task for analyzing a large amount of text. But it is known that it is not easy, actually difficult problem. And the difficult problem, one of the difficulty is in the disambiguation process, because we have place names with the same spelling but different location. So we have to disambiguate that this place name actually refers to one of these place name, candidate place names. And GeoNLP has an ability to disambiguate automatically based on location, class, and other factors. Of course, the accuracy is not perfect, but we can do this using a Python program. Where GeoNLP is developed by, as a Python program, so you can use it from the Python. And it is only designed for modern Japanese, but pre-modern Japanese text may be possible in the future. Actually, the modern Japanese and pre-modern Japanese, it has a difference in the grammar and vocabulary, so it's not easy, but we're thinking about applying it for pre-modern Japanese text in the future. The last project that I'd like to briefly introduce is called Memory Graph. Actually, it's a mobile app, but you cannot download now because of the problem in a Google Play. So we are developing a new version, but we just show it as an idea of how the app can be used if it's available. So it is a new photographic technique to create a layer of memories. And you can easily, I think you can easily see the idea. So we have old photograph like this. So what is how the landscape has changed since then? It is around the photograph of around 1900. So you go to this place and take a photograph from the same location and same direction and the same scale, so that you can directly compare two images. So I introduced the vdiff.js before, but this app is doing the same thing for the real photograph. So if you take a photograph like this, you can, the current landscape is like this. So you can see that the road is actually existing now, and also the church is also here, but the building has changed. And we also thinking about applying it to see a change before the disaster and after the disaster. So this is a result of this is a photograph of the earthquake, the landscape just after the earthquake, and then it is recovering. And of course, this place also looks different now. So this kind of comparison, visual comparison, is also useful for spatial analysis of the landscape. And if you collect these kind of historical data, the long-term goal is, I think, historical big data. And we collect the data from many historical sources, and the historical sources contain many kinds of information in the past. And then one type of data is nature data, like weather, earthquake, eruption, and these days, disease information is also important, like Spanish flu 100 years ago, which is recorded in the old historical sources, and extracting it and use it for the research is important for understanding the past and also thinking about the future. We also have cultural data like economy, population, politics, and culture. So we create a data structuring workflow for the integrated analysis of historical big data. So this is a historical big data project that we are working. And so the data structuring workflow, we start from handwritten characters, and we digitize the old books, and we have digital image. And after that, we transcribe the data to get plain text. This part is actually done by CuRoNet, by Dr. Tarin Karanwa by CuRoNet. But after that, we have a many long process to create the analysis-ready data, so that we can analyze it using a computer program like simulation and so on. And so we have to do many kind of tasks to starting from handwritten characters to the analysis-ready data. Okay, as a summary, I think I talked too much, but visual and spatial digital humanities research as a summary. And digital humanities is not only about text. This is what we are always thinking about. And especially visual and spatial sources need its own analysis and interpretation framework. And so digital humanities starts from sources like books and maps and the photographs and so on. And machines can help many tasks in the data structuring pipeline, like cropping the objects and transcribing the characters and so on. And interoperable data formats such as IIIF plays a critical role in developing a new data platform, as IIIF creation platform is one example. And also humans and machines can collaborate for the transformation of humanities research. And yeah, traditionally humans work, and machines can help, but machines cannot give answers directly for humans. So humans and machines should collaborate. So thank you for listening to my talk. And this presentation includes research results from CODH researchers, Chikaiko Suzuki, Mika Ichino, and Tarin Karanwa. And we also have software developers like for the IIIF creation platform, Jun Homa and Alex Zayer. And some results are also based on the work of internship students that I have been accepting, and many data from National Institute of Japanese Literature. So if you are interested, please visit our website, CODH ROIS-DS CJP, and collaboration is welcome. So thank you very much.